Welcome to Industrial PLC Applications. This video is on Connected Components Workbench, our first program. It is step 4, creating a rung of logic. This video assumes that the program Connected Components Workbench has been downloaded and installed on your computer. This video is step 4 of 5 in the series. Alright, so we're going to be working on our workspace. In the last video we just created a program and we opened it and there was a blank rung. Now there's a few things you should be aware of. When a rung is active, that is as you're going to edit it, you're going to have the left hand power rail highlighted in blue, and then you can start to edit. The other thing to keep in mind is this black line represents the rung itself. And if you're an electrician, if this was the line 1 and this was line 2 or the neutral, this would be considered dead short. Some other programs, some other PLCs, dead shorts are not allowed. They will actually cause either the program not to be downloaded or cause a fault on the processor. So we want to avoid that. So our first rung of logic, I'm going to show you how to create a placeholder. Now I try to do this in every program that I do, as I create what I call a header rung. And it basically gives me a blank space to put some comments to explain to the reader what it is we're trying to program. So to do that, I have to go to the instruction menu bar. If you don't see that, there's 2 small arrows on the side, and the last person, if it wasn't you, may have hidden it. So take the top one and just drop it down and your menu will pop back up. So you need to add an instruction, and there's a spot for favorites. So if you're using something all the time, you can drag and drop it into your favorites and they will appear up here, quick and easy to get to. So I'm going to use one that's called a no operation instruction, or nicknamed a NOP. And since this is highlighted, I should just be able to click it, and I'll click it twice and there are 2 of them. Now this is a placeholder. It doesn't do anything for the logic. I could leave that and it's not considered to be a dead short. It's perfect. Okay, so I'm going to now create a new rung, because that's the whole point of this exercise. So up here on our menu bar, you'll see this one that looks like a big letter H, and if you put the mouse cursor to it and wait a second, it'll tell you what it is. Oh, that says rung. Because this is highlighted, I can simply click on that and it will add me a new rung. Just as simple as that. A lot of the things that Allen-Bradley's put into their software, they've put quite a bit of thought into it, and they're trying to make it intuitive and as friendly as possible, so good job. Alright, so let's move right along. We want to add some contacts. When you're writing your first rung of logic, much in the same way that the ladder logic that it's based on, we start from the left, we work across to the right, we do one rung at a time, then we go to the next rung and the next rung. So it would be, from your viewpoint, left, solve the logic to the right, go to the next, left, solve the logic to the right, etc. Alright, so we're going to put a contact, and we've got a couple different to select from. We have a direct contact and a reverse contact. We would used to call those normally open and normally closed. They also have another acronym name called examine if closed, or as I like to say, execute if charged. So to add that, again, I just have to click on it. It's going to put it on this rung if I click on it now, because the first rung is highlighted. If I want it on the second rung, I just click it here. The default is that instructions go anywhere closest to the left-hand rail and outputs go anywhere to the right-hand rail. So I'm going to, just to demonstrate, I'm going to grab an output, and you can see when I clicked on it, it put my output and it stuck right over by the right rail. So the convention is that the last thing on your rung will be an output. In the real world, if I was attempting to do, say, a motor starter, I would put the overloads after that, because the overloads will open up and take power away from the starter, and the starter will drop out. Not in PLCs. I cannot put those contacts there. It's not going to work. Now, this by itself is almost a complete run. The only thing is I have this yellow attention triangle. So when you're creating a run, these attention triangles are telling you that you're not done. So there is nothing associated with this particular contact. Now you notice when I move my mouse, it hovers and a little box appears. That's because the program needs to have a point of memory. It says, okay, well, what am I supposed to be looking at? What am I turning on? So in this case, you click on it and a little drop-down box will appear. If you type something, you're going to create. If you want to use something that's already existing, then you just see the drop down below it, and I'm just going to arbitrarily take the very first output. Notice that if I scroll this down, there's no inputs. So this whole explanation or stands for inputs and outputs underscore embedded module, and then DO for digital output, and then the actual address. Now addresses are referring to terminal screws on the actual unit device or on the actual I/O device. So if you add an I/O device later on, that's the terminal screw. If you had to go and find it with a screwdriver and a tester, etc., you would find it at location 00. So, believe it or not, that's a complete run. That will work. The first one is called a header run, and it's just strictly for information. There's a box above it that turns blue that you can type in information, or commentary what it is. For example, if I double click on it, you're going to see a new box up here, which looks like a text editor, because lo and behold it is. I'm going to increase it so you can actually see the font size. This is a header run. Next person knows exactly what the purpose of this. I would put information about the project. The second part is, this is actually a working run. Now it only has one application. This run is called an unconditional run. There's nothing preventing it, or there's nothing preventing it from starting, and also nothing to stop it. The only way we can stop it is to turn the PLC from run mode to program mode. That'll turn it off. Or we kill the power to the PLC, or if it's on another panel with the disconnecting means, we kill the disconnect. We're not controlling it. To do that, we have to put a contact ahead of it. So in this case, we're going to take our contact, and because this is highlighted, again, I just have to click that contact, and it's going to show up the first logical, legal position to be in. So I'm going to go back to our little blue box, because I've got to what am I looking for? The PLC says I have no idea, because that's what my hand's up for. I think a little attention box of being in school, you're like, teacher, I don't know what they're doing, okay. All right, so we're going to put the little box there. And these are variables that are available to us. And we're going to drop down until we see our I/O, EMDI, I/O, embedded module, digital input, 00. And now I have a way of turning that on and a way of turning that off. So in the next video, I'm going to show you how to save this so that you, as they said many, many years ago when I played a computer game on an old IBM XT, save early, save often. So we're going to do that in the next video. See you then. Thanks for watching. Our next video will be step 4, creating a rung of logic. Thank you for watching.